it's time for the last section of Chapter 9, and there's really not much to say about it. It's a review section, so I thought we'd never make it sometimes there. But if you're making a confidence interval for mu, mu is the population mean, right? If that's the case and you want to estimate mu, the population mean, you're going to use x bar as your point estimate, your single best guess, which is the sample mean. Just keep in mind that's what a point estimate is. Point estimate is single best guess, right? Keep that in mind and that'll help, right? It's a single value, it's your best guess, best estimate. All right, so what distribution do you use if you're talking about the mean? Well, that's the t distribution. We learned about it today, invented by the guy that worked for the brewing company. The type of interval is a t interval, so that's the shorthand for it. We learned it in section 9.2. Oopsie. There it is. 9.2. There we go. Let's see. Oh, and the formula. The formula is the x bar plus or minus. I cannot get that unbolded. There it is. All right, I'll go back up and get it. Oops, passed it. Oh, I'll be right back. There it is. There's the formula. So it's the x bar plus or minus t alpha over 2 s over the square root of n. All right, so that's if they're talking about mean. So if you see the words average or mean somewhere in the problem, that's what they're talking about. Now what about p? P is the population proportion, right? Population proportion. Okay. Now your single best guess for a population proportion is a sample proportion. Like that. It's p hat, which would be equal to x over n, right? Well, now what distribution do you get to use for this? This is the z distribution, which makes it a one proportion z interval. One proportion z interval. Now we learned that first thing. I know it was kind of strange, but we learned it in section 9.3. Okay, let me go get the formula for that. I'll be right back. Poof, there it is. Right from section 9.3. It's the p hat plus or minus now z. Notice these are z's as opposed to these ones which are t's. There's the formula. So if you see percents, proportions, any of that stuff talked about in the problem, this is what they were working with. They're working with proportions, and this is the kind of interval you want to make. This is particularly important because all sample surveys like Gallup and CNN and Fox News and all of that, they all work off of those. Okay, now what is sigma squared? Sigma squared is the population, population variance. Okay, and sigma is the population standard deviation. Oops, come here. STDV. Okay, and then what have you got to work with? Well, you'll have s squared, which is sample variance, and then you'll have s, which is sample standard deviation. Okay, these are your best guesses. These are your point estimates of these ones. S guesses at sigma, s squared guesses sigma squared, respectively. The distribution you get to use, let me go make that symbol. Hold on. Oops, did a little work there for a second. So it's the chi-square distribution. That's the symbol for it, chi-square, which means it's a chi-square interval. Okay, you learned it in section 9.4, and this is the formula for variance. You take the square root, of each for standard deviation. Okay, so you just have to know that to do it. All right, so if they're talking about in the problem somewhere estimating the variance or estimating the standard deviation for the population, then you're doing a chi-square interval. All right, that's all there is to it, and we are done with chapter 9. All right, I'll see you back here on YouTube for chapter 10.